multiply or divide. So we're going to multiply and divide the numbers. Then we're going to use exponent properties on the tens. And then the other thing we're going to continue to look at is electromagnetic waves always travel at the same speed. In the electromagnetic spectrum, there's a spectrum of types that vary in frequency, which we're going to represent as this like fancy V, and wavelength, which will look like this. So the wavelength multiplied by the frequency will always equal the speed of light, which will be represented as C. So speed of light, right, when we have wavelength, just to hammer this down, and we have frequency. So let's look at some examples. Example 1. A radio station has a frequency of 960 megahertz and a wavelength of 0.3125 meters. We're going to find the audio speed. So we're going to use the following below. So like our equation. And instead of using 960 megahertz, we're going to use 9.6 times 10 to the 8th hertz, right? Because this mega can be substituted as times 10 to the 6th. So then we had 960 times 10 to the 6th, but we want to put that into scientific notation, so we get this number. Then we also need to put our wavelength into scientific notation, so we get this. So now let's solve for C. Now, remember we're just going to multiply the numbers together. So let's get our calculators out. So we have 9.6 times 3.125. So we get 30. So when we multiply 9.6 times 3.125, we get 30. Now, notice we have times 10 to the 8th and times 10 to the negative 1. Well, all we're going to do is actually, right, we can go like this. What do we do with that? Well, since we have the same base, we're actually just going to add them together. So 8 minus 1 is equal to 7. So we get 30 times 10 to the 7th because we added these together. Notice we aren't done. We need to convert 30 to scientific notation. So we're going to convert 30, and we're going to go 3.0. So that means we move the decimal here to here. So since we have a larger number than 1, that means we have a positive exponent, and we just moved over 1, so we can just go like something like that. So 3.0 times 10 to the first. Then we still need to add this, so we have 10 to the 7th power. Now we have the same base. We just go ahead and add our exponents. So our answer becomes 3.0 times 10 to the 8th power, because 1 plus 7 is 8. And now we can use this as our C for the following examples, because we found the speed of light, which is 3.0 times 10 to the 8th. When you look this up, the speed of light, notice we rounded for this. Now let's do example 2. Example 2. What is the frequency of purple light with a wavelength of 410 nanometers? So we're going to use the equation below, the speed found in example 1, and instead of 410 nanometers, we're going to use 4.10 times 10 to the negative 7. Now, just a quick little thing, not that you have to know this, but nanometers, like the N, we can be substituted as 10 to the negative 9. And since it is 410, we can go ahead and what happens is this 410 becomes 4.1 times 10 to the second. Then we keep this times 10 to the negative 9, so then it becomes, right, if this comes down, we get 4.10 times 10 to the negative 7. So that's where that number comes from. Not that you need to know that, but it's just kind of good to see. Now let's go ahead and solve. So for this problem, we're going to go ahead and divide. So we have this 3, and we're going to go ahead and divide it by the number below, which is 4.1. So let's get our calculators out. So we're going to go 3. I'm going to go ahead and divide it by 4.1. And what do we get? Well, we get a decimal. So we get 0.7317. And we'll just end there for decimal places. So what does this become? Well, this becomes 0.7317. Notice that we still have times 10 to the 8th below. Then what happens to this? Well, we could go ahead and divide by times 10 to the negative 7. Or we can go ahead and bring it up. And when we bring it up, it becomes positive. So this becomes times 10 to the positive 7. Because we brought it to the numerator. So whatever we bring up to the numerator from the denominator, it would become a different sign for this times 10 to the whatever number that is. So now let's go ahead and keep solving. So let's just keep this as is. Now we have times 10 to the 8th, times 10 to the 7th. So we go ahead and just add these exponents, right? So we have times 10 to the 15th power. But notice we're not in scientific notation. We need to move this decimal between the 7 and the 3. So this would become 7.317. So because we moved it over 1 and to the right, that's times 10 to the negative 1. And this is times 10 to the 15th still, right? This still stays the same. Now let's go ahead and add those exponents together, and what do we get? Well, we get 7.317 times 10 to the 14th. And this is 4 hertz, or 1 over seconds, which is the same thing as hertz. Now, what if you aren't sure you're right? Well, let's pull our calculators out again. So I'm going to show you. So if we were to clear all, put on our calculator 3.0 times 10 to the 8th power. And we're going to close the bracket. Then we're going to go ahead and divide by this, in parentheses, 4.1 times 10 to the, let's go negative 7. Well, look at that. We get 7.317 times 10 to the 14th. So we got the correct answer. So if you weren't sure if you did it right, you can always check it like that, or you can go ahead and solve for like that. But it's always good to know how we come about it with getting the exponent right and our number right. But that would be our solution. So 7.317 times 10 to the 14th.